we are discussing the memory-based question of GATE exam 2020 instrumentation branch, which was held today only. So this is the sixth question of digital electronics based on sequential circuit, and the topic is synchronous counter. Let me first read the question for you, then we will discuss the solution as well. Present state of a synchronous counter is QA/QB is equal to 1 1. In the figure also you can see both the clock pulses are synchronized. So it is a question of synchronous counter. So the present state of synchronous counter is QA/QB is equal to 1 1. If X is equal to 1 0 1, you can see in the circuit X is an external input and X is applied as 1 0 1 in the subsequent clock cycles. The decimal value of QA, QB, Y is fill in the blanks. Decimal value of QA, QB, Y in decimal is that also after 3 clock pulses. So it was given in the question that you have to find the value in decimal after 3 clock pulses. See, if there is no external input in any of the question, in a question of synchronous counter, then it is very easy to solve with the help of next state equation. And in the table, we will have only 2 columns, present state and the next state. But if external input is given, and that also, if a particular sequence of that external input is given, you will have to take help of a tabular method. We will solve this question using a complete table. So let me start drawing the table for you. See, the first column in the table, will be present state. So present state is QA, QB. Present state is QA, QB. Then external input. Next column can be external input, which is small x. Now, with the help of this information, we can draw the column of flip-flop input. The flip-flop input TA is connected to NAND gate, so it is QB dot X whole complement. And the next column TB is connected with the external input X. Okay. And if we know the information of the flip-flop input, we can go for the next state. That is QA plus 1 and QB plus 1. And output of both these states into the OR gate will give you the external output. Y. So let me complete the format of the table and then we will start filling the table. See, it is clearly given in the question that the present state is 1 1 and input X is 1 0 1. This is clearly mentioned, 1 0 1. So this is the table that we can continue. Now, we know QA, QB and X, so we can go for TA and TB. NAND gate of QB and X both are 1, so NAND gate output will be 0. X directly copied will be 1. What happens in T flip-flop? If TA input is 1, it will toggle. If T input is 0, it will not toggle. It will not toggle means it will hold. So TA is 0, hold. So state 1 will hold. And TB is equal to 1, flip-flop B will toggle. Toggle means 1 will toggle to 0. So after the first clock cycle, state is 1 0, which is applied to the OR gate. So 1 plus 0 will be equal to 1. 1 plus 0 is equal to 1. After the first clock pulse, the state is 1 0. After the first clock pulse, state is 1 0. So output will be 1 plus 0 is equal to 1. Now, this is the next state 1 0, which we will make as a present state to find out the next state. So we'll continue in this manner. Okay. Now, NAND gate QB and X. So NAND gate output will be 1 and X is directly equal to 0. Last time flip-flop A was in hold state and B was toggle. This time A will toggle and B will be in the hold state. A will toggle means, flip-flop A will toggle means 1 will toggle to 0. And flip-flop B will hold means this will be 0. So A will toggle to 0 and B will hold at 0. This is after the second clock pulse. So whenever we find the next state, this is always after the clock cycle. Okay. So after the second clock cycle, the state is 0, 0 and output of the OR gate will be 0 plus 0 will be equal to 0. Now this 0, 0 we will continue. We will continue with this 0, 0. Output of the NAND gate QB is equal to 0. Output of NAND gate will be 1. X is 1. So this will be directly copied here. This will be directly copied here. Okay. Now TA is 1. So flip-flop A will toggle. Flip-flop A will toggle. It will toggle from 0 to 1. And this is TB is equal to 1. So flip-flop B will toggle from 0 to 1. So A and B both are in toggle mode. Both will toggle from 0 to 1. This is the situation after the third clock cycle. This is the situation after the third clock cycle. So after the third clock cycle, the state is 1, 1. Output of OR gate will be 1 plus 1. That is equal to 1. It is saying in the question to find QA, QB and Y after the third cycle. So after the third cycle, all the 3 bits are 1. So if we want to convert it to decimal, this will be 7. So answer of this question is 7. So QA, QB and Y after the third clock cycle, answer is it is asking the answer to find in decimal. So answer is 7. So 7 is the answer for this question.